So today we're going to start the absolute value inequalities. Our first step is to get the absolute value by itself first. Then we're going to break the problem into two problems, one where the inside is normal and one where the inside is opposite. Once the absolute value is alone, you can determine the type of problem it is. So if absolute value is less than or equal to, it's an and problem. And it can help you maybe to remember the word land, L for less than. So if it's less, it's an and. Greater than or equal to represents an or problem. And you can remember the word GOR, G for greater, and then or. So again, remember, and problems, we're looking for the overlap, so they need to be on top of each other, where they both are true. Or problems, they're usually pointing away from each other. It's kind of like an Oreo. So the outside, and then there's nothing in the middle. There are exceptions to both, but that's the general rule. So we're going to start by solving the absolute value inequalities, and then we're going to represent our answer on a number line and inset notation. So for problem 1, I realize, oh, there's my absolute value bars, but there's a 2 on the outside. So I need to move that first. I'm going to divide both sides by 2. We get absolute value of x plus 1 is less than 6. And I'm going to put it into my 2 problems. Right here, absolute value is by itself. It's less than something, so this tells me it's a land or an and problem. My normal side, x plus 1, is less than 6. And then my opposite side, negative x minus 1, is less than 6. We're going to solve, so for the left, I subtract 1, x is less than 5. For the right, I'm going to add 1, negative x is less than 7, and divide by negative 1. So x is greater than negative 7. So we have negative 7, we have 5, 0 somewhere in the middle. X is greater than negative 7, so it's going right. X is less than 5, it's going left. They are open circles, just like in the compound inequalities, because that means I'm getting super close to by not equaling them. And it's going to be everything in between. That's where they overlap. My set, x such as negative 7 is less than x less than 5. For problem number 2, I've got absolute value of 1/2 x, and I'm subtracting 4 is greater than or equal to 1. The first thing we're going to do is get absolute value by itself. So right now there's a minus 4. We're going to do the opposite, add 4. So absolute value of 1/2 x is greater than or equal to 5. Because absolute value is by itself now, I can decide if it's an and or an or problem. Absolute value is greater than, so it's GOR or. I do my 2 problems, my normal, 1/2 x is greater than or equal to 5, and my opposite, negative 1/2 x is greater than or equal to 5. For the left one, I'm going to multiply both sides by 2. So x is greater than or equal to 10. For the right one, I'm going to multiply both sides by negative 2. That's the reciprocal of negative 1/2. So x, remember when we multiply by negative, we flip the symbol, is less than or equal to negative 10. On my number line, negative 10 and 10, 0 somewhere between. At negative 10, it's going to be a filled in circle because I can equal it. X is less than, so it's going to go left. At 10, it's going to be another closing circle because I can equal it. X is greater than, so it goes right. And it does look like an Oreo.